sure why the black stuff's hanging around the screen. All right, go ahead and start copying this down. Today is the third. What we're going to cover today, angle relationships, how angles are related to each other, things you should be able to do, name special pairs of angles. We're going to talk about 3 or 4 or 5 different special pairs of angles. That means how 2 angles are related to each other. Find measures of angles and identify, Robert, what's this upside down T mean? All right, Josh.
Perpendicular.
Perpendicular. So identify perpendicular lines. You have 2 lines that intersect. They form angles. So right now, real quick on your paper, what I want you to do is just draw 2 lines that intersect each other. Doesn't have to look like mine. Don't label it like mine. Just draw 2 lines. You don't have to write this down. All I want you to do right now is draw 2 lines that intersect each other. When you draw 2 lines that cross each other, maybe you draw something that looks like this. It makes absolutely no difference. How many angles are formed? 4, always. All right? Of those 4 angles, there's like 7 or 8 special pairs of angles in that diagram. No matter how you drew yours, if I look at this angle and this angle, what looks to be true about those 2 angles? If I could draw my arrows pointing in the right spots. They look the same. I don't care how you draw 2 lines, if they intersect each other, these angles that are across from each other are always going to be the same. It's physically impossible to draw it any other way. What's always going to be true about the other 2 angles here? They're always going to be the same. If I redraw this picture, I draw some other 2 lines that intersect each other. Doesn't matter what it looks like. Some of you may have drawn something that looked like this. Some of you may have drawn something that looked like that. Something like this. It doesn't make any difference. Can anybody tell me what looks to be, if I number these, or what's true about angle 1 and angle 2 there? Maybe make it a little easier if I get rid of this. Maybe. They add up to be 180. Together, they form a what? A line. The straight angle or a line. So those are another special pair of angles we're going to talk about. All of those, that's what we're going to deal with today, and you're going to set up equations from all that stuff. We're going to talk about the definitions of all those different special pairs that you have. So if I look up here, what do I know about angle 1 and angle 3? They got to be the same. How about 2 and 4? They have to be the same. What do I know about 1 and 4? They add up to 180. They add up to that straight angle right there. What about 1 and 2? They add up to 180. How about 2 and 3? Same thing. 3 and 4, same thing. So there's all those special pairs of angles in that picture. All right, go ahead and copy this down. Angle 1 and angle 2, we just talked about this. You told me that they add up to be 180. They're also called adjacent angles. And we'll talk about that. I'll give you some. To be adjacent angles, if I trace angle 1, give me an angle that's adjacent to angle 1. 2. All right, so if I trace angle 2, notice, and this is what the next slide is going to tell us, what's true about angle 1 and angle 2? They share a vertex, and what did I trace twice? They share a ray, a side there. All right, they share a side or a ray. Those are adjacent angles. 2 angles that have a common vertex and they share one side are said to be adjacent angles. Just like my room and Mr. A's room, we share a what?
A wall.
A wall. That's like the ray right here. So that's what makes our rooms adjacent. Miss Hoffman's room, not adjacent to my room, because we don't share a wall. So that's what adjacent angles are, and that's what this next slide is going to tell you. The definition of adjacent angles. Now with adjacent angles, it looks like here, when we draw a picture like this, they also have to add up to be how much? 180. That's true with this certain picture. If I was to draw, I should have used my other pen. If I was to draw this, angle 5 and angle 6, are they adjacent angles?
Yeah.
Yeah, but are they, or do they add up to be 180?
No.
No, not necessarily. So adjacent angles are angles that have a common vertex. That's what this says. They have a common vertex and they share a side, or they have a common side. Which angles are adjacent in that picture? Give me one pair. Weston, give me one pair. 1 and 2. Angle 1 and angle 2 are adjacent angles. Brittany, give me another pair of adjacent angles. Angle 4 and angle 3. Very good. Give me another pair. Marissa, give me another pair. 2 and 3. Angle 2 and angle 3. So on, so on, so on. All those are pairs of adjacent angles. Little more important, vertical angles. Go ahead and write this down. As you write this down, awesome. Why is it doing stupid stuff on me? As you write this down, might want to put about 1,000 asterisks around it. Just like with the word congruent, when we talked about that, very, very, very important that you can pick out vertical angles. If you can't pick out vertical angles in this classroom within the next couple of weeks, you're probably not going to do very well. Definition of vertical angles: pairs of non-adjacent. What do you think non-adjacent means? They don't share a side. All right. So pairs of non-adjacent angles formed by intersecting lines. So it's the angles that are the ones that are not adjacent to each other. Those are vertical angles. You guys already told me, just going by that, you told me that 1 and 2 were adjacent. So give me an angle that's not adjacent to angle 1.
3.
Angle 3. And you already told me what's true about angle 1 and angle 3. They gotta be congruent. They're always exactly the same. What other two angles here are vertical angles? 4 and 2. They have to be the same as each other. This is going to lead us into, we're not going to cover it as of right now, but in chapter 2 we will. Anytime you have vertical angles, it's the shortest theorem that we're going to cover all year long, and probably the easiest theorem we're going to cover. And it says vertical angles are what to each other? Congruent. That's going to be like one of the first theorems that we cover. Vertical angles are congruent. It's just a mathematical rule. You draw two lines and they cross each other. No matter how you draw those two lines, the two pairs of vertical angles in the picture will always be congruent to each other. Always. Which angles in this picture are vertical? C and A. What's the other pair? Please never, ever, ever name your angles this way with letters in there. If you put numbers in there, that's okay. Never do it this way. I put this on here because last year, 2 years ago, I can't remember when it was, the OGT test had angles named this way. All right? Terrible, terrible way to name angles. You should never, ever do it this way with capital letters inside the angles that way. If you use numbers inside, that works fine, or letters around the angle as points, that works fine. But this is a totally improper way to name angles. We already talked about this, so I'm going to skip over this. Vertical angles are always congruent. These two are always congruent. These two are always congruent. All right, I'll give you a second. Go ahead and write this down. All right, two angles are said to be supplementary, so supplementary angles, and if it helps you to write it down a different way, maybe the best way to write this down, the definition of supplementary angles. Supplementary angles are two angles that add up to be 180 degrees. So supplementary angles are two angles that add up to be 180 degrees. So looking at this picture here, name me two angles that would add up to be 180 degrees. Josh, give me two angles. 4 and 1. So angle 1 is supplementary to angle 4. Austin, give me another pair. Angle 3 and angle 2. So angle 3 and angle 2 are supplementary angles. That's all supplementary are. Now, it doesn't have to be a picture. It looks like this for angles to be supplementary. If I give you this angle and I tell you this angle is 70 degrees, I give you another angle that's completely separate from it, and I tell you it's 110, those two angles are still supplementary to each other because they add up to be 180 degrees. The other part of this, a linear pair. Two angles are considered a linear pair. It's pretty self-explanatory. Again, this goes back to geometry being a lot of common sense. What's pair mean? Two. What's the root word here? Line. So these are two angles that together make a line. So name me a linear pair in that picture. 1 and 2. 4 and 3. 2 and 3. 1 and 4. All those pairs that Brian just named, not only are they a linear pair, but they were also what to each other? Supplementary. Not only were they supplementary and a linear pair, what other name that we talked about earlier are they to each other? Adjacent. All right. Now, does that mean that all pairs, if they're supplementary, are going to be a linear pair and always going to be adjacent angles? No. This picture right here shows that these two could be supplementary, but they're not a linear pair and they're not adjacent to each other. Could be other angles. Angle 5 and angle 6 there are what to each other? Adjacent, but are they a linear pair? Are they supplementary? No. So you got to know which one you're dealing with and where the picture's at. The key thing here, the one that we're going to use the most, the supplementary, because that tells us that this angle and this angle have to add up to be 180. So if you knew that this angle was 60 degrees, then you could find the measure of angle 1 by subtracting that from 180. Two angles are complementary angles. then they add up to be 90 degrees. Please be sure when you're talking about complementary or supplementary, it's always two angles, not three angles, not four angles, not five angles. It's two angles that add up to be 180, or two angles that add up to be 90. If I draw that picture, what's this little box in the corner tell us? It's a right angle, 90 degrees. All right? So that little box tells us it's a right angle, 90 degrees. If I draw some other ray in here, what do we know about these two angles? They're complementary. Not only are they complementary, but these two are also, what's the other name? Adjacent to each other. So there's all kinds of different ways you could put these things together. The main thing here again, if I told you this was 2x, this was x, what equation could we set up from that? 2x? Is that what you said? Right. You said 3x. Sorry, Robert. 3x equals 9. What Robert did there, this angle plus this angle should add up to be the whole right angle because they are complementary to each other. And then you would solve and you could find x and you could find each angle. That's a lot of what we're going to be doing. That's messed up. Angle 1 and angle 2. Right, what kind of angles are angle 1 and angle 2? Supplementary. Emma says she doesn't believe you. She thinks they're called something else. What else are they called, Emma? They're adjacent angles. Peyton doesn't believe either one of you. He thinks you're both wrong. He thinks they're a linear pair. What's true about all three of those names? They're all true for that one picture. Angle 3 and angle 4. Please do not do what I'm getting ready to do here. Angle 3 and angle 4 are what kind of angles to each other? Complementary. Don't do that after today. All right? Why am I telling you not to say that these two are complementary? They're adjacent, that's true. But why can't we say that they're complementary? What don't we know? If that's 90 degrees or not. All right? You need that little box in there or them to tell you that those two form a right angle before you can decide that. So these two angles, if I draw that box in there, they're complementary. And what other name could we give angle 3 and angle 4? Somebody else said, I think. Adjacent. About 5 and 6, what kind of angles are they to each other? Vertical. So if I told you angle 5 was 72 degrees, what's angle 6? 72 degrees. What kind of angles are these right here? Stupid thing. Why do I keep switching from the... What's on pin? What kind of angle are those two angles? Supplementary. Are they a linear pair? No. Are they adjacent? No. What kind of angle are these two? Complementary. How about these two angles?
They're just adjacent.
Those there, those are adjacent. How about angle 7 and angle 8 right there? What kind of angles are they? Complementary. I can move this box here without it messing my whole screen up. What kind of angles are these two angles to each other? Adjacent, supplementary, linear pair. Write this down. Lines that intersect to form four right angles are called what?
Perpendicular.
Perpendicular. Perpendicular. The symbol for perpendicular. We talked about this back at the very beginning, the very first slide. Symbol for perpendicular. What is it? Symbol for perpendicular is that upside down T. I don't want you guys going home and watching this video over and over again, just laughing at me because I'm having so much trouble, all right? It's not funny. Somebody read that to me. Line AB. And this is what you're going to see a lot this year. Line AB is perpendicular to line QR. And then what you need to be able to do is come out here, draw line AB, draw line QR, be able to draw the picture that they're explaining to you by the information they give you, and know that all four of those angles are right angles. Don't forget that the box in the corner tells you a right angle. All right, I'll give you a second, write this down. All right, looking at this picture. Let's figure out x. How could we set up an equation to figure out what x is?
5x plus 10 equals 90.
5x plus 10 equals 90. Very good. So this right here is that angle. Well, they told us that angle was a right angle. Not sure why I'm using this marker instead of what I'm supposed to be using here. Five x plus 10 equals 90, because we knew that that angle there was a right angle. Somebody tell me what they came out with for x if you solved that. 16. Everybody agree with that? Now, they're probably not going to ask you to figure out what that angle is by plugging back in x, because what do you already know about that angle? It's 90 degrees. So if we plug back into there, what would you come up with? It's 90 degrees. So that doesn't really help us any. How could we set up an equation to find y?
Combine like terms.
Before we go that far, you're ahead of everybody. What can you tell me about that angle? And this angle. They add up to 90. They're complementary angles. All right? So now what equation can I set up? So this plus this stay on the screen there. This angle plus this angle has to add up to be that right angle right there. Now we collect like terms. 18y plus 9 equals 90. Then what?
Subtract 9.
Subtract 9. Subtract 9. 18y equals
81.
81. Then what?
Divide by 18.
Divide by 18. Don't grab your calculator because I don't want to hear it. Without using your calculator. Anybody figure that out?
4.5.
4.5 because Brian probably already punched it into his calculator and cheated. What again?
Whatever.
Dividing is the same as having a fraction. What's wrong with this fraction? It'll reduce, right? What will go into both 81 and 18? 9. How many times will 9 go into 81? 9 times. How many times will 9 go into 18? So you end up with 9 over 2. Now, can you divide that in your head probably instead of have to grab your calculator? How many 2's are there in 9? 4.5 or 4 with 1 left over, right? So 4.5. Start being able to do stuff like this. Use your brain instead of grabbing the calculator. If you can do this, it's going to make everything else so much easier as you do math. Okay? Once we know all that, looking at this picture, what can you tell me about the measure of angle AGF? Angle AGF.
It's
90 degrees. Right there. This one's a right angle. This one has to be a right angle because together they form straight angle 180. What can you tell me about the measure of angle AGC? It's a right angle. What's the other? Somebody name the other right angle in this picture for me. Yeah, we already got that one. EGC also has to be a right angle. What can you tell me about line AE and how it's related to line FC?
perpendicular.
They're perpendicular to each other. Very good. What else can we figure out here? Yeah, that's about it. Just follow along. First, name me an acute angle in this picture. WYT is an acute angle. Angle WYT, which is right here. Which is right here. Name me two complementary angles. What's complementary mean again? They add up to be 90.
YWU.
UW. Hold on, I heard this one first. UWT and TWY. Everybody agree with that? UWT is right here. TWY is right here. Those two add up to be 90. We're not sure, except for if that's a right angle, what's this whole angle over here on this side have to be? That has to be a right angle, so that's correct. Give me two others in this picture that are complementary. VXU and angle WYT. Little different than the other two we named. How'd you know that these two were complementary? Because one of them's 30, one of them's 60, and that adds up to be 90. Name me a pair of, here, and I'm not even going to have you name me a pair. Let's, I'll change my pen color here. Let's do a blue one. Somebody's going to come up and grab a pen. We want to find two vertical angles. So take a second, look in the picture. We want two vertical angles. What has to be the case? Give me a vertex where we're going to have vertical angles in this picture. U. So we're going to deal with U. So one of you is going to come up, trace an angle at U. Then I'm going to have the next person come up and trace the angle at U that's vertical to that. You want the harder one, Brian, or you want the easier one?
Oh, which one's harder?
The second one.
Okay, I'll do the first one.
All right. So then Brian will do the second one. So Brian's going to trace an angle that has vertex at U. Brighton's going to watch closely. All right, have my pen back. Because I got to change the color. Does everybody see the angle that Brian traced? Somebody name that angle for me real quick while I'm doing this. VUX, angle VUX. Now we're going to have Brighton trace the angle that is vertical to that one. Does everybody see that? So what do we know about this angle and this angle? They're vertical angles and they're also equal or congruent to each other. Are there other vertical angles in this picture? Yeah, you got this angle right here, has to be vertical with this angle. Where's the other point where you have vertical angles in this picture? Point T right here. You've got to be able to pick all that out and say, hey, I know that these angles, this angle is going to be congruent to this angle. This one is going to be congruent to this one. Be able to pick all that stuff out. These little tick marks here. What's that tell us? Not line. What is it? Segment. What segment? Segment ZB is congruent to segment ZW. Why not lines?
Because there's an endpoint on each.
You can't measure lines, so you can't say that they are congruent to each other because they go on forever. Why are they not rays? They go on forever too. Same idea as lines, right? So if they're showing you that, hey, this is the same as that, then they have to be segments, not either of the other two. You're going to work these 4 problems. I'll walk around, try to help you while you're working them. Then I'll put the homework assignment up here. Then Robert's going to come up because he's acting like he's so wore out and tired that he can't do anything. He's going to come up here and he's going to work all 4 of them for you afterwards. Probably not. But we'll have to see if he's actually working diligently. Then I probably won't force him, and I might even let him pick 4 people who he wants to come up here and work them out. I guess. Makes sense. All right, your assignment. You got about 12 minutes or so. You can start working on this. You can put it right there on the same sheet of paper. If you have questions, I'll come around and help you.
You're recording that.
No, I'm getting there by a second. And then I'm going to stop it here again. if I'm recording this and you're watching the video, you like to see the assignment at the end when you.
Yeah, but you can pause it at the end.